irreversible process. In reversible process, the changes are carried out so slowly that the system and surrounding will always remain in a state of equilibrium. And in an irreversible process, the change is brought about too rapidly, very rapidly, and the system does not attain, just mark the word, does not attain equilibrium. So, that is about reversible process and irreversible process. Now, next thing, a spontaneous process. As the word suggests, spontaneous means by itself. So, spontaneous process may be defined as the process which can take place by itself or initiation. We can have examples in this case. One which take place by themselves are evaporation of water in a vessel, dissolution of salt in water, or flow of water down a hill. If we flow water from a hill, it will come down. So, such processes are known as spontaneous processes. So, spontaneous process are those processes which take place by themselves. Then those which take place by initiation, for example, if we light a candle, ignite it, it will get lighted, or combination of oxygen and hydrogen to form water. These are the spontaneous processes, they will occur, we cannot stop them. So, they are spontaneous process. The other type of process is non-spontaneous process, which cannot take place by itself. For example, flow of heat cannot take place from cold body to hot body, or water cannot go uphill, or sand cannot dissolve in water. So, all these processes are non-spontaneous processes. So, this is about spontaneous process and non-spontaneous process. Now, we would be discussing about certain other quantities like internal energy. Every system is associated with a definite amount of energy, and this energy is called internal energy. It is represented by E or U, and it depends upon various factors such as temperature, pressure and chemical nature of the substance. Then change in internal energy. It is the difference in the internal energy of the products and the reactants. Delta E is equal to EP minus ER. So, internal energy, what is internal energy? It is the amount of energy that is associated with a system. Then enthalpy. Enthalpy or heat content may be defined as the sum of internal energy and the product of pressure and volume. If H is enthalpy, H will be equal to E plus PV. So, this is enthalpy. Then change in enthalpy again. It is the difference in the enthalpies of the products and the reactants. Delta H is HP minus HR. This is the enthalpy of product and this is the enthalpy of reactant. So, basically what is enthalpy? It is the heat content of the system. Internal energy was the energy associated with the system, and enthalpy is the heat content of the system. Mind it, be very clear. Internal energy is the energy of the system and enthalpy is the heat content of the system. Then there is another term, entropy. Entropy is a measure of the randomness or disorder of the system, and the greater is the randomness, the greater is the entropy. Entropy of a crystalline substance is minimum in solid state and maximum in gaseous state. Let us take an example. For suppose we have melting of ice. Ice is solid, it has very less randomness, very less freedom to move. So, it is less random, less entropy. Water, movement is more. So, water has more entropy. So, entropy is a measure of the randomness or disorder of the system. So, we have seen the three terms: Internal energy is the energy associated with the system. Enthalpy is the heat content of the system, and entropy is the randomness or disorder of the system. Now, in short, I will be discussing about the laws of thermodynamics. We have 4 laws of thermodynamics: the zeroth law of thermodynamics, the first law of thermodynamics, the second law of thermodynamics, and the third law of thermodynamics. Zeroth law states that when two bodies are separated in thermal equilibrium with the third body, they in turn are equilibrium with each other. For example, we have two bodies A and B, and they are in equilibrium with the third body, touching a third body. So, they themselves are in equilibrium with one another. This is the zeroth law. Then we have the first law of thermodynamics, which states that energy can neither be created nor destroyed, although it may be converted from one form to other, and the total energy of the universe always remain constant. So, first law is, just remember this point, energy can neither be created nor destroyed, although it may be converted from one form to another form. You have to just remember the definitions. We do not have much in our syllabus for your diploma level. Then the second law, it is delta U, that is the change in energy, is equal to Q plus W, where Q is the heat content and W is the work done. This is the mathematical expression. Then second law of thermodynamics. The second law of thermodynamics states that all spontaneous or naturally occurring processes are irreversible. We have seen what is a spontaneous process, which occurs by itself. So, all spontaneous processes are irreversible. We have seen what is an irreversible process also. Spontaneous process will occur by itself, so it cannot be reversed. So, such processes are irreversible. This is the mathematical derivation. Delta S is equal to, total delta S is equal to delta S of system plus delta S of surrounding. The total entropy of the universe must tend to increase in a spontaneous process, and in a non-isolated system, the total energy of both the system and the surrounding must increase. Do not go into all these definitions, only the first definition is important. Then the third law of thermodynamics, it states that the entropy of all perfectly crystalline solids may be taken as 0 at absolute temperature, or at absolute 0 a perfectly crystalline solid has a perfect order of its constituent particles, that is, there is no disorder at all. Hence, absolute entropy is taken as 0. So, the third law of thermodynamics states that the entropy of all perfectly crystalline solids may be taken as 0 because there is no randomness in perfectly solid substances. So, this is the third law of thermodynamics. Let us revise the three laws again. The first law states that energy can neither be created nor destroyed, although it may be converted from one form to other. The second law states that all spontaneous processes are irreversible, and the third law states that the entropy of all perfectly crystalline solids must be taken as 0 at absolute temperature, because at absolute 0 a perfectly crystalline solid has perfect order of its constituent particles. So, this is about the laws of thermodynamics. I will just discuss in short what all we have discussed today. We have discussed the three laws of thermodynamics, the first law, the second law and the third law. Then we have discussed about the important quantities like entropy. Then we have discussed about enthalpy, internal energy. We have discussed internal energy, enthalpy and entropy. Then we discuss about spontaneous process and non-spontaneous process. Before that, we discussed about the reversible and irreversible process. Then we discuss what is a cyclic process, the various types of processes like the isothermal process, the adiabatic, the isochoric and the isobaric. Then we discuss, before that we discuss what is a process. Then we discuss the various terms like state function, state variable, state of system. Before that, we discuss what are extensive properties, what are intensive properties. Then we discuss what is a homogeneous system, what is a heterogeneous system, and the various types of system. And before that, I discussed what is thermodynamics. So, we started with thermodynamics. We studied the system or definition of system, surrounding. Then we discussed the various types of system, that is the open system, the closed system and the isolated system. Then we discussed the types of system, that is homogeneous and heterogeneous system. Then extensive and intensive properties. Later on we discuss what is the state of system, state variable, state function, then process, then the various types of processes like isothermal process, adiabatic process, isochoric and isobaric. Then later on I discussed about cyclic process. Then what are reversible processes, what are irreversible processes. Then we discuss a spontaneous process and non-spontaneous process. Then we discuss certain important terms like internal energy, that is the amount of energy, enthalpy is amount of heat, entropy is the randomness or disorderness of a system. And later on we have discussed about the laws of thermodynamics. As per your syllabus, we have studied 4 laws of thermodynamics. The zeroth law, which states that two bodies which are separated and are in equilibrium with the third body, they too are in equilibrium with each other. We have discussed about the first law of thermodynamics, which says that energy can neither be created nor destroyed, but may be transferred from one point to another. Then we discuss about the second law of thermodynamics, then which states that all spontaneous or naturally occurring processes are irreversible, they occur by themselves. Then later on we discuss about the delta S is equal to delta S of system and delta S of surrounding. Then we have discussed the third law of thermodynamics, which says that entropy of all perfectly crystalline solids must be taken as 0. So, today we have discussed about the basics of thermodynamics that are up to your level. I hope you people have understood all the terms, all the types of processes, the laws of thermodynamics that we have studied today. Again and again I have been repeating all these. Thanks a lot. Thank you.